Okay, good day everyone. My name is Michael Newton. I'll be presenting this webinar on our Herbert-ABS's HECSTAB offshore stability program. We're going to be going through a tutorial that we've put together with this upcoming release that we think is kind of be useful and helpful for new users and experienced users to kind of learn about going through the process of doing an offshore stability analysis. Showing some of the design considerations, as well as how to use the program to quickly and accurately do these analyses and to put reports together at the end. I put my video on here just to say hello to everyone here, but for the most part, I'm going to keep my video off, and I'll be going through and presenting the software and going through this tutorial document. A few quick notes. So I do have my colleagues Brandon and Chris are both here as panelists. The Zoom webinar feature should allow you as panelists to have capability to chat or to ask questions, and hopefully Chris or Brandon will be able to get back to you on anything that you have while I'm going through my presentation. I do hope to have some time at the end to take any questions or hear any comments or requests at the end of this webinar. But if you want to put some questions in now or as I'm going through things, by all means, feel free. So I'll turn my video off here, and I should be sharing my screen. So this webinar, as I said, is going to be going through and going through a tutorial, a step-by-step kind of process of how to go together and do a high-level intact or damage stability analysis using our HECSTAB package. This is something that we're starting to do here with this webinar, and we're hoping to make this into a kind of recurring series where every month we'll put together a topic that we're going to try to do a little more of a deep dive on or provide more information on over the month. So, we'll try to mix it up. We can use our software package for a lot of different aspects. I think some of the ideas that we've had for looking forward for upcoming tutorials is maybe doing a little more detailed dive into how to generate and how to create writing arm criteria files and how to do all the special things and interesting situations that can come up from writing arm evaluations. We've also talked about doing a tutorial or a demonstration on our tie-ins with Rhino 3D modeling. We'll probably do one in the not too distant future looking at our salvage and emergency response features as well. So keep an eye out for all of those items as they come up. For now, we are going to be going through this offshore stability tutorial. This will be included in our next monthly release, which will probably come out by the end of this week for those of you that are on the annual maintenance subscription plan. So this tutorial basically is going to go through and give a high-level overview of what it takes to set up an analysis, to perform an analysis, and to get results out to do an intact or damage stability analysis for an offshore structure. We're going to be looking at a semi-sub model here. And we're probably just going to start with a quick overview of what the model is and what we're looking at. So I have a model here in our ship project editor tool. This is what we are going to be basing our analysis around. So this is a semi-submersible production vessel type design. It's symmetric. It's got 4 columns and obviously 4 pontoons. If we look at what we've put together in our ship project editor, we can see that we've got our basic hull structure defined. If I look at how this was put together, we basically pieced it together from a bunch of different pieces that we defined and were able to model and put everything together. This tutorial or this webinar is not going to put a lot of time into the modeling side of things. We do have other tutorials and other documents to help you put models together, but just kind of looking things at a big picture, you want to be able to define the geometry of the hull and all of the internal compartments or the watertight spaces within. And that's what this model has. And again, this semi-submersible demo model is included with our sample data with the install package. So when you have access to this new release, you'll be able to take a look at this model and to investigate it as well. A few things to note here that I just wanted to show, just looking at the basic particulars. It's a decent sized semi-sub. We've got an overall LBP and a beam of 91.5 meters. And as I said, everything is symmetrical transversely and longitudinally for the most part. There's a few special cases for some internal compartments. We have put together the hull model, and it's made up of a bunch of pieces, and we have put together the compartments by group. So we've broken up and looked at all of the internal spaces. Everything is modeled internally. If we're looking primarily, we have, the main group would be a saltwater ballast group. We can see that we have all of our pontoon tanks are basically defined as ballast tanks, as well as a couple column tanks as well. We've got a large number of voids that cover up all the other spaces in the model as well. And then we've got a few kind of specialized items for, some small diesel oil tanks, some freshwater tanks, a couple slop tanks, and production vessels or storage compartments as well. So taken all together, this model is a pretty complete representation of the external hull form of this design, as well as all the internal compartmentation. Before we do an analysis, we need to look at a few other things. Number one, for most offshore platforms and most offshore analyses, a lot of the criteria are going to be based around wind overturning moments. With our software package, we do have a number of ways to define this, where we have direct calculations of overturning moments. We can have calculations based on simple 2D profiles, or you can have, if the information is available through other means, you can just simply have a table of overturning moments or coefficients. So for this example, in this demo ship, we've basically just have predefined a number of wind overturning moments to use in the analysis. This will probably be another subject of one of our upcoming webinars, where we could really go into detail on how these numbers can be calculated, looking into our wind overturning moment calculation tools, and looking at some much more advanced and more detailed features on this calculation. But for now, just note that we've got wind overturning moments, a kind of a matrix of them that are based on wind heading direction at a number of drafts and at a number of inclinations as the vessel heels over. So this is going to be pretty critical to any offshore analysis when you're looking at something like a MODU criteria, where the wind overturning moments are a big component of the analysis itself. Another kind of important aspect of doing an intact stability analysis is going to be checking for down flooding or submersion of down flooding points. So again, in our model, this is kind of what you would expect from a preliminary or an early design stage, where you might not know the exact locations of your down flooding points and which connections are which connected to which tanks and things. But if you put some limiting or some representative down flooding points in, that would be the worst case you could expect or something like that, then we can run this analysis with some basic watertight, either weather-tight components or unprotected components. And again, writing arm criteria in many cases are going to look at how far these are from being submerged as you heel the platform or heel the vessel over. So we've defined down flooding points in our model. And then finally, if I go back to my compartments by group, it is nice to have this space type defined. This will help when we go through the analysis, defining what the permeabilities are when you start looking at damage stability. Every regulation is going to have different requirements for the permeabilities that you can use. So we've basically specified, the important things here are specifying which tanks are ballast tanks, which tanks are, or which spaces are voids, which spaces are machinery spaces that might have a slightly different permeability. So again, when we do the analysis, we'll see that there's a very simple way to say, if we have the space type defined, that we automatically can assign the appropriate permeability for this. The one last thing I want to look at here at the model before I go on is we do have in our modeling software, we have a model review. And I always recommend that people, whenever they put a model together, that they run this and take a look at what it says, because this is kind of our way of saying, based on the information you've entered, here are any data or any validations or any information that we've noticed that might have either been entered incorrectly or might be missing or might indicate that something was modeled incorrectly. So we can see in this model, it's got a couple minor warnings showing up. We didn't define any draft sets. We don't have any marks defined. We don't have a wind profile defined, but we do have a wind, a set of wind overturning moments defined. So that should be okay. I've noted some of my loads, my LCG is outside the center third. That can sometimes indicate that there was some misentry, but it also just means that these might just be some weirdly shaped tanks. So they're just simply warnings. I can see I've got some very minor comments here, but in general, this is a very clean model. There's no errors, nothing that's showing up in red. Everything looks good here. And then if I look at my available analyses, this is basically saying, based on this model, based on the information that's entered, I have access to doing trim and stability from tables, trim and stability from offsets, and damage stability. Those are going to be the three primary analyses, or the three primary calculations that I'm going to be interested in this situation. So very nice, very clean model for us to work with. Obviously, we put this together as a demo, so we were able to massage this and put it together so it has everything that you need for what we're looking at here. So that's the modeling and an overview of the model itself to start with. And now we're basically just going to transition over to the HECSTAB. I actually had this open. I'm going to start from scratch just to make it clean. So I'm going to go ahead and start our HECSTAB package, and I'm going to load up the semi-sub for this, the semi-sub demo for this analysis. Which should be showing up here any second now. Oh, here it is. So I'm going to browse to my semi-submersible, and so I'm loading up my model in HECSTAB, and it's loading on my other screen. I'll bring it over here in a second. Okay, so you should be able to see my HECSTAB window. This is basically just starting with a brand new clean analysis. I've got my display set up how I like to see it. I've got my Condition Explorer tree on the left-hand side, a 3D view down here, and my entry tables and my displays, just set up how I like it. Obviously, we're starting from a brand new clean analysis, so I don't have any conditions defined. There's nothing to actually look at this point. And this is kind of where I just like to discuss HECSTAB and the ideas behind HECSTAB in general. To do an intact analysis or to do a damage analysis, you can use the program to set things up however you want and to use the interface to create conditions, to create a condition tree or an analysis tree that would have your drafts and set your spaces. You could do everything in the program by hand. But obviously that can be quite time consuming and detail oriented. So what we've tried to do is we've tried to make it so that for some standard analyses or some standard, repeatable processes, that we can give you a very simple way to go through the process to create a full analysis. So that's where we think one of the most powerful things of our HECSTAB software comes in is this idea of an analysis package. So for this demonstration, I'm going to be looking at primarily two analysis packages. Number one is going to be the off-axis max kg. This is going to be the basis of our stability analysis itself. So once I load this package, you'll notice that I get a new item on my ribbon bar, off-axis max kg. And this is basically giving me the tools, the analysis templates, and actually has a link to the tutorial document itself that I can load up and show the tutorial, the PDF itself. But the idea here is the main aspect of this analysis package is going to be these analysis templates that walk you through the process. So we're going to start with an intact max kg analysis template. So if I run this template, this brings me up a second window here that basically is showing me the steps that it's going to take to do a basic intact max kg analysis. So this is a package that we ship with our software. But the idea is, and we are encouraging our clients to take a look at what goes into these and hopefully be able to modify and expand or create these analysis templates for themselves for the tools and the stability or the analyses that they do regularly. In this case, it's just a very basic intact max kg analysis. So we've got basically 5 steps to go through to define a max kg analysis. Number 1, define variables. Here's where we've basically specified the items that we want to be able to either change or customize when we're doing an analysis. For this demonstration, I'm just going to leave everything as a default here. But you could, play around with, which healing angles, which heading angles you wanted to use. If you wanted to run full calculations for all headings, we'll look at this setting here in a second once we run the analysis. That kind of speeds things up a little bit. I can look at my defined calculation settings, stability. Here's a case where maybe our defaults, my writing arm curves, I don't need to do every 2 degrees. I can say I'm just going to do every 5 degrees up to 50 degrees. So here's where I'm going to tell the program, this is the writing arm. These are the writing arm angles that I want you to evaluate for each condition. Looking at the next step, we have our defined calculation settings, wind. Again, I said that when I was looking at the model, we have a number of ways to define or to calculate the wind over turning moments. In this case, we're just going to use the wind table lookup data, but you can specify direct calculation or using profile or outlines as well. And then I have a design factor, and just to speed things up and to kind of exaggerate the analysis here, I'm going to kind of really focus on making this wind dominant. So I'm gonna put a design factor of 5 on my wind table, and this is just going to make it so I can see my wind over turning moments, and we can see that where the criteria, the analysis are actually starting to fail and pass. And then the second to last step here is going to be selecting a GC criteria. In this case, we're going to do a very basic MODU intact stability analysis. So again, within our program, we ship quite a number of the standard GC criterias. There are a seemingly infinite number of these criterias out there in the world. So we can't stay on top of them all. We try to do the main ones, but we do have tools that can allow you to generate and create the specific criteria for your region or your area or whatever needs to be done. But this is just a very basic intact stability, MODU, column stabilized units, normal operating. So if this was the analysis that I needed to start with, I've got my writing arm criteria selected. And then finally, I can pick which drafts I want. You could do a very high level. In this case, I'm just going to copy and paste in a range of 5 drafts just so we can run the analysis here. But basically, these 5 steps have now allowed me to define my intact stability analysis, and I can hit this run analysis package, and it's going to automatically create the conditions in my HECSTAB tree. I can see I've got my start condition, and I've got my 5 draft conditions set up underneath. I always like to show off in the user interface, this hierarchy, we call this our condition explorer, and we always try to kind of show this as a hierarchical inheriting type of situation where any settings that are set on a higher level will pass down into lower conditions. So we would consider this a parent condition, and these are the children of this parent condition. So on our start condition, if I look at my summary of my local changes, we can see that we've set our basic calc settings. Here's where we set those angles for the writing arm calculation. Here's where we set the wind design factor. So all of these are set at the highest level, and so they'll pass down to each of these conditions. For each of these draft conditions, we can see that we've basically added 2 tools. We've added an adjust water plane tool that's going to get me to this draft, and then I've got this heel axis evaluator, which is going to create the off-axis conditions that I want to evaluate against. So just kind of a quick overview of how our inheritance and our condition setup works here. But for now, what I'm going to do is I'm just going to start running the analysis. So we can see as it goes along, I'm doing my 20-meter draft. I'm doing the tool itself is generating these conditions underneath. And then for each condition, for each heading, this is where it goes back to those settings in the initial analysis template. I set this to the quick and to pass sibling. So it's basically saying, okay, I'm going to start at my heel axis of 0. I'm going to do a maximum kg analysis here. I'll adjust the kg, And so we can see in this case, we've gotten to a point in our alarms where we've maximized the starting intact kg so that we are just passing the IMO MODU's stability for column stabilized units. So I can expand here. I can see my writing arm curve. I can look at my analysis down here. I can see that I've got my writing arm angles. I've got my downfooting angles. I can see that I'm checking my GZ is positive up to the second intercept. So that's a true item. My ratio of restoring area to overturning area. And this is kind of where we see that this is where it's limiting. So we've adjusted the starting condition VCG to the tipping point where we are just passing, this criteria. If I raise the starting VCG any further, then this would obviously go into the ratio would decrease and I would go into a failure. So that was all done on this one heading. And so now we've got an intact kg of 36.469. So for the next heading, we started at that 36.469. But in this case, it actually reduces, so I can only go up to 33.707 here. And so for the next one, again, it's lowered a little bit, 32.692 for this heading. And now we see a bunch of conditions with passed siblings. So that means that it started with the 36.692, it passed, so that means that it's not going to be the limiting heading angle. And then finally, we get down here to this last heel axis, 135. And here's where it's kind of found the worst case, 32.481. So for this draft, we've looked at these 15 different headings, and we found the worst case. And basically for this analysis, for this criteria, as long as I kept my intact max kg under, or as long as I kept my intact VCG under 32.481, I would be insured to always be able to meet my MODU writing arm analysis or writing arm criteria. And so it's done that for all 5 drafts as well. I can expand and look and see. I think in most cases, it's always going to be failing on this 135 axis. I think that's because of the geometry of the design itself, but I also think it's probably a function of the wind moment in this direction might be the highest, or the wind overturning moment would be the highest in this direction as well. So we've done a very basic intact stability analysis here. If I go back to my ribbon bar, I can see that I have some data tables I could look at. I have some reports I could look at. If I wanted to, this might take a couple seconds, but I'll click the intact max kg off axis button here. This will bring up a kind of a report that we've put together that is going to show just a basic table of here's your draft, here's your maximum VCG, here's the critical condition for it is. So, here fundamentally, this is the basic end result of this analysis that we wanted to do. We wanted to get this writing arm or this maximum kg analysis, maximum kg curve. And so we've got a very simple tool to look at this. At this point, I want to take a step back though and go back into my intact max kg analysis template. So this was one set of drafts, one GZ criteria, 5 drafts. I could go in here and kind of iterate on this. I could refine my draft sets. I could change things if I wanted to. What this is actually doing is really cool because it's this analysis template. A user using this only needs to enter numbers, but what's actually happening behind the scenes is this is actually creating a Python script that is using our HECSTAB API to run this entire analysis. So the actual analysis template is creating this Python script. I'm not going to go into a lot of detail on the scripting itself, but for people that are programmers or that have access to or knowledge of Python programming, the sky's the limit basically on what you can do, not only in the user interface and with these analysis templates, but just writing code to do really detailed or really complicated analyses as well. Just to show you a very, very simple aspect though. So what I wanted to do here is I can edit this script and I want to add this as a child condition. And I'm going to call this MODU normal. So this is the only thing I'm doing is just adding an additional layer to the tree. So if I run this script, I'm going to see the same general setup over here in my condition tree, but this time I've actually added one more layer. So on my start condition, I have my summary information. Oops. I've got my local changes for all my settings. If I go to this tree, now I've added, this is where I'm adding my criteria for my Modu normal operating, and then I have my drafts under here. So this is where you could actually start using the interface. I could say, okay, well, let me do my normal and my severe storm. So I can duplicate this branch. So now I've got the same thing here. I can rename this, and I'm going to call this Modu severe storm. And then all I need to do is go to my tools. I'll take off my normal writing arm criteria, and I'm going to I'll add my intact stability for severe storm. So now I've got the same analysis tree, but I've basically set it up to do the same, but this one's going to give me my normal Modu criteria. This is going to give my severe storm criteria. So I'll go ahead and get the calculations running here. It should only take a couple seconds. So again, it kind of shows the power of the condition tree and the inheritance of the child and parent situation here, where I've defined all the inputs and I have this really neat little setup here, and I can easily duplicate that, make a minor change at the top, and have all my other settings down below. So this is so now I've run my Modu normal analysis, and now I'm doing my severe storm analysis. And what I set this up, the reason I set this up this way is on the reporting side, we've done a whole lot recently to improve and to allow for customization of actual reporting. And so if I have a condition tree that's set up like this, where I have a start condition, and then I have one or more nodes that are defining a GZ criteria with a writing arm evaluation or a maximum KG evaluation underneath them, we've actually put together a Word document template and a Python script that will put together an almost complete intact stability report to put everything together, not just getting the data out. So if I go to my Python script editor, I'm going to open up a script that I have. And again, this is going to be included with the sample tutorial data. I can open this script. I have it saved under my models, semi-sub tutorial. So intact stability assessment booklet. So this is a script that we've put together to try to actually make an entire document that can be used to put an intact stability report together. I'm not going to look at the code too much, but I'm just going to run it. It's going to ask me a couple things. Number one, it's going to ask me for the template to start with. So this document file has our cover page and our template and a lot of the wording that we're going to see once this is done. So I'll select that. It has some prompts to update things. Like if I wanted to add a reference, I can say, yeah, my reference one is going to be, sample reference document number 1. So I'm just going to add the one reference. It's going to think for a little bit. It takes a little bit of time for it to put all the data together to create the graphs and the plots and the pictures and the printouts that go into it. We should start seeing it processing some of the conditions here shortly. I'm going to grab a sip of water while I'm letting the program run. So you can see it's gone through, it's processed most of the conditions for the normal. I think we'll start seeing it process. Yep, here come the severe storm ones now. So it's basically putting an entire report together. I think there's going to be one more prompt here in a second, asking for revision notes. So again, just something that we can say this is going to be revision 0, original release. I'm the author. And I'm the approver. Hit OK. Don't need to read. So that's basically finished this Python script to put a report together, and it's sent everything to Word. And so basically from HECSTAB, I have created this entire document that has a cover page that I can fill in the blanks for. So this is all coming from that document template that we started with. It's got our standard copyright on it. It automatically added the revision notes that I put in during the script. It's added a table of contents. It's added a reference document where I put in that sample reference document. It's got some boilerplate information here that, again, you could fill in the blanks, choose a criteria, have things, most of the wording is here. You got to fill in the blanks a little bit yourself. Then we've added sections for putting in the downflooding points. We've added sections for the intact stability calculations. Here's the summary, the overall settings of, here's our normal max kg curve, here's our severe storm, and also our governing max kg curve. I got the table of the values themselves, and now I've got entire appendices full of the detailed results itself. So I've got a curve and the data just for my normal situation. And then I've got, condition printouts for all of the weak cases. So here's my draft 20. This is my weak axis here. We can see what the results were, the trim stability summary, the weight summary. Obviously, the important part would be the writing arm evaluation itself of this situation. And now we've gone up to draft 25. So we've put this entire report together just using a Python script. And, this is probably, 90% of the way there to having something that you would be able to, put the final details into and send to class or send to the client for review or for approval. So that's a quick whirlwind overview of an intact stability analysis. What I'd like to do next is to look at how this changes on a damage stability analysis. So I'm going to go ahead and go new project. I'm going to clear out everything that I've done here. I'm not going to worry about saving anything here. So again, I'm back to a clean starting point, nothing in my condition tree, no analysis, no conditions defined here. If I go back to my off-axis kg, I can see I do have a damaged max kg analysis template. If I click on this, again, it's very similar to the one we were looking at for the intact steps, the intact stability analysis. The first, I think, 5 steps are all the same, and then we've added 2 more steps at the end for defined tank properties and defined damage cases. So this is obviously where the changes happen. Before I start going into this in detail, it's a little bit more interesting to take a step back and say, okay, well, if I'm doing a damage stability analysis, how do I know what damage cases I need to run? And this is where we have an additional analysis package called damage case generation tools. So if I load this guy, I can see that I actually have 4 analysis templates that can kind of walk me through automatically generating damage case sets based on specific criteria. So we've got scripts put together for MODU surface and self-elevating, MODU column stabilized, IBC and MARPOL. This would be for ships carrying oil, IGC, the International Gas Code, again, ships carrying liquefied gas. So this script, if I look at my IMO MODU column stabilized damage cases, this is a script that basically just it gives you an overview. It's saying, based on this criteria, this script is going to automatically generate damage cases based on the requirements in this code. So in this case, it's a horizontal penetration of 1.5 meters, a vertical extent of 3 meters, ranging from 3 meters below to 5 meters above the defined draft. And then a remote flooding flag so this is actually looking at, you can have collision damage and you can have remote flooding damage. So we can generate one or both of those sets. And then if I'm looking at the defined variables, there's a lot of settings that go into it. The idea behind the script itself is you're defining the draft, you're defining a number of steps to kind of move around and define a damage box to find the damage cases. There's options for only looking at the largest possible damage. It's looking at options of combining small tanks and consumable tanks and treating them all as one tank and things like that. But basically, this script is defined to basically set a draft. And I'm going to clear the plan, yes. And if I run this, So at a draft of 10 meters, it's going to go through and run a script that's going to find all of the damage cases that are applicable at that draft. So in this case, it took it a couple seconds and it went through and it found, looks like it found 44 damage cases that it's automatically generated. So we can run through those real quick if I look at my loads and just show the damage cases here. So maybe I can make this bigger. So we can see as we go, we can see it kind of stepped around and it found all of the possible damage cases that meet the requirements or meet the restrictions of the MODU damage stability criteria. So at this draft, obviously it's actually hitting a lot, because at the 10-meter draft, our pontoon is at 9 meters. There's a flat here. There's a lot of different combinations of damage cases that it can actually hit at this point. So it found quite a large number. If I were to go back and rerun this again, I could say, you know, if I went up to 25 meters and run the analysis, this is a case where maybe I'll probably find a few less damage cases. We'll see what it comes up with here. Yeah, this time I only got 32. So I can see again, I'm higher up on the ring. I'm not damaging any of the pontoons, but it looks like I'm damaging, this is the extents are actually hitting the top of the columns as well. So this is kind of where the design process, the design spiral comes in to, you know, this model itself was defined to be pretty discretely segregated. If I look at my model, if you look at things from just a big picture standpoint, you realize that this flat here at the 9-meter draft where the top of the pontoon is, there's going to be a lot of cases where either above or below you're going to be hitting a lot of zones, and then maybe a middle case where you're only hitting one range. And then there's another big flat here at, I think, 28.8. So any damage around this is going to be hitting both the bottom and the top and any combination of those. So when you put a damage analysis together, you're going to have different damage cases based on the draft itself, and you need to know which draft range the draft cases themselves are applicable for. So for what I've put together, I've primarily focused at understanding the requirements around this flat and understanding the requirements around this flat. So if this is at 9 meters and this is at 28.8 meters, then if we think about it, if I have a damage extent that goes 3 meters below and 5 meters above, then the critical drafts that I'm going to be interested in are going to be maybe 9 meters up to 12 meters. Once I get to 12 meters, then my 3-meter extent below would no longer start hitting this. So anything above 12 meters, you know, within this range is going to be the same damage set until I get to basically 5 meters below this flat, at which point then I'm going to start hitting, you know, both cases here. So my critical drafts and you have to kind of think a little bit critically about where these draft cutoffs are and where the damage cases are going to transition from, you know, and the extents are going to transition from having one set of damage cases versus another set of damage cases. So I put this together. So what I did, and to kind of simplify this, is I've run a damage generation, and I'll go ahead and do it one more time here. So I did a damage generation for a 10-meter draft, and I run this analysis, and it basically gets me all the damage cases that are going to be hitting the pontoon and hitting this you know, this first layer in the column. And like I said, we've got 44 damage cases here. And what I can do is I can export this as a condition branch. So I want to save this as a branch data, save an HIN. And I'm going to call this new damage. This is a 10-meter draft. So I've got this HIN branch is basically, it's saving all of the information, kind of the input information that defines all of these damage cases. And I can do the same for the drafts that makes the most sense for this analysis. And then, so in that case, if I go back and just look at what I've previously saved, So I've got HIN branches for 10, 15, 25, and 35. So those were the representative drafts that I ran. So now if I go into my off-axis max kg, I'm doing a damage max kg analysis. Define variables. I'm not going to change too much here. I'm just going to change the kg tolerance, although it probably doesn't even matter. I'm going to load up the results here. Change my calculation settings. Again, I can just define the range of my GZ curve. Change the calculation settings. Again, I want this to be wind dominant, so I'm going to really crank up the wind on this. Select my GZ criteria. This time I'm doing IMO mode damage, and we're just going to look at the collision stability. So collision stability for column stabilized units. I'll select that criteria, and then I can define the draft set. And this is where we can kind of, again, go back and look at the model and say, where are the critical drafts where I'm switching damage cases? And basically that would be, if I started at a 9-meter draft, and then I could go up to a 12-meter draft, and those would all have the same damage cases. Basically the damage cases for anything where both the pontoon and this first layer of columns are damaged. Once I get to 12.01, then those pontoon damage cases are going to fall off. And then that would extend all the way up to 23.79, because 23.8, now we are 5 meters from this main flat in the middle of the column where we would start picking up new damage cases. So in this case, from this range, 12.01 to 23.79, I have just the damage cases of kind of the one column set. But then once I get to 23.8, now I'm actually hitting these upper damage boxes as well. So I have a much larger set of damage cases where I'm damaging both the lower and upper portions of the column. And then that would go all the way up to 31.8. At 31.8, now we are 3 meters above that 28.8 flat. So now at 31.81 and above, so we'll just say up to 40, this would have the damage cases that are just, the upper portions of the columns. So it took a little bit of time, a little bit of thought to think out where the kind of logical breaks are for these, but I can define all these drafts. And then finally, so for each of these drafts, I have a step here at the end where I can define damage cases. If I was to use this step, then the idea is that this damage case list would get used for every draft. But as we said, we want individual damage case sets for each of these drafts. So that's where those previous HINs come in, where we save those files out. So I can select on my D9 draft, I can hit my, I think this has a tooltip, add damage branch to selected draft. So this I can pick my, I can say, in this case, it's my 10-meter damage. That's going to basically apply for anything from 9 to 12. So again, this guy is going to have the same thing. He picks the 10. So we've got 44 damage cases for these two drafts. Now that we're on 12.1, I'm going to pick my damage cases for, I just picked an arbitrary draft of 15, but this is basically going to be the 20 cases where it's just the columns before it hits that first flat. 23.79, same thing. I pick a 15 draft, so I've got my 20 cases there. Now at 23.8, we're at a point now where we're 5 meters from that 28.8 flat, so we need the damage cases that are going to have both sets. So I think that was where I had said a damage of 25. So again, we've got a lot more damage cases now. That goes all the way up to 31.8. So I pick my 25 here. And then once I'm above 31.8, then we're just damaging the items at the top. And that's going to be my 35 set. That's only got 10 damage cases. Obviously, there's only a small number of compartments that are being, or small number of damage cases that are applicable up there. So now I've set up all of my drafts. I've got 2, 4, 6, 8 drafts. I've got, my damage cases assigned for each draft. I'm almost done. The last thing I want to do is define my tank properties. When we're looking at damage stability, you want to apply and select a damage permeability. You can see that it's taking in some numbers from the model. Since this is a MODU criteria, I just want to assign the Imo Permeability. So there's a button here, and now we can see it's basically set everything to 0.95. I think machinery spaces might go down to 0.6. I thought we had some of those, or 0.85, I think. Did I see one? Yeah, here's a machinery where it's 0.85. So just a very simple aspect. As long as your model is set up correctly, that it's going to assign the permeability correct. And so here's the full damage stability analysis template put together. And again, I can run this analysis. It's going to clear off everything over here. And it's going to set up each of my drafts. For each of my drafts, it's going to have the appropriate damage cases in it. So my draft 9, again, I have my 44 damage cases. If I go up here to the top, I've only got the 10 damage cases at the top. You can see here, I've got my upper damage cases versus my lower damage cases. And so here's basically the full damage stability analysis that's ready to go. This is the part where the calculations, we've got a whole lot of damage cases. We probably have, even without doing the headings, we've probably got, we've got a total of 221 individual cases, and you figure each one of those is going to have 15 headings that are going to be created automatically. So we've got 1,000, 1,500, maybe even 3,000 cases that we need to run. That would take a little bit too long for this webinar, so I'm going to do a little shortcut, and I'm going to open the project where I've actually ran this last night that has all the information run and in it. So pretend like I hit the run all button and we sat around and waited for it to finish, but in reality, this is just loading up the project from that was previously run before this webinar. So we can see we've got our drafts. We've got all of our damage cases. Each damage case has each of the headings specified, and we can see there's a weak axis here. If I look at this guy, oops, let me get my view back to how I like it. So I'm on this guy. I'm draft 9, my damage case 44. In this case, my weak axis is here. I can look at my loads. I see that I have this is one northeast ballast column damaged. It's a pretty big one in the corner. If I look at, I moved the wrong thing. That's what happened. If I look at my results, I can see that in my alarm summary, it's converged. If I look at my criteria, we've got a case where we've got a healing arm. And again, this is where we put that design factor of 10 on. So it's quite exaggerated in this case, but it was just something so we could kind of see some reasonable results. I've got my analysis for my GZ criteria. In this case, we're looking at the first angle of intersect with the healing arm. We're looking at the watertight and weathertight downflooding angles. We're looking at the freeboard, must be 4 meters above the water line, so we're easily meeting that. This is obviously a low draft, so that should never really come into play. I've got a positive range, and I've got a maximum healing arm and GZ ratio. Obviously, here's where we kind of are hitting the limit. So again, we've got a maximum KG. We've done our analysis. This is the worst case for this damage case. And obviously for this draft, you would want to try to figure out and pull out the weakest out of all of the cases as well. So again, there's tools, there's ways and scripts that come in similar to what we looked at on the intact side to generate these for word printouts or things like that. We also have data tables that we can add. So in this case, I can do minimum max kg by draft. If I look at this guy, let me move him over here. No, wrong thing. Sorry, let me move him over here so we can see. So this is basically giving me a table for each of my drafts that I ran, what the maximum kg was and what the limiting kg was, and I can see the path. So in this case, for my draft at 9 meters, damage case 7 was limiting. For 12 meters, again, damage case 7. Once I got to 12.01, then it switched to damage case 3. So I can see which of my individual cases, what my damage cases were, what my maximum kg was, so on and so forth. I could also look at the maximum kg by damage list if I wanted to see each one. Again, I can see for each of my drafts. Let me sort this by draft again, or let me just look at. If we wanted to look at like this 40-meter draft, I can see here's my 10 damage cases for each of these damage cases, my headings. You can see it varies. Some were at 120, some were at 45, one was at 30. So, you know, there is a good reason to look at the headings for everything around the vessel. Here's the maximum kg for each damage case, and obviously you would find the worst case is this draft 40 damage case with these two items damaged. Case 3, this is going to be your limiting max kg overall. Whew. So that's kind of how to do a damage stability analysis in HECSTAB. I know I went through things very quickly, and I wanted to try to touch on as many things as I could, both on the intact and damage side during this hour. But I have left us a couple minutes here for some questions or comments, or if anyone has anything they'd like to go back and look at. So at this point, I would open up the floor if you have any questions or comments, or I guess Chris or Brandon, if there's anything that you've answered while I've been talking that maybe you want me to touch on a little bit more, please let me know. Were there any questions? I'm reading through the chat here. It looks like there was a question from Wei Ying about adding the adjust kg to all children. That's what the template, the analysis template itself, if we go back to the damage max kg template, if I look at the script, you know, in the script itself, we can see that it's adding the adjust water plane tool. Here's where you get to the draft. And then down below, we've got all these damage cases. So there's a ton here. In the script itself, we can see we're adding the heel axis tool in the script. And then we're adding the heel axis. If we're running max kg, we turn the kg adjust tolerance to true. So that's definitely a case where the script is doing a lot of the work. If you were trying to create this by hand, there would be a lot of manually adding condition tools and doing things like that. There's another question. Is there a tool to plot or develop the weight versus TCG curve? I'm not sure if I know what that's meaning. We've had discussions about doing things like V curve, trying to find the locations of the allowable location of down floodings, and we have some scripts and some outlines for scripts that would do those types of tools, but I'm not sure what you mean by a TCG curve. If we have a relatively small column or a pencil column, can we adjust the damage extent by considering this column is not effective for automatic damage generation? That's a good question, and that kind of goes back to when I was looking at the damage case generation tool. In the script that we have this idea of small tanks and small volumes and medium tanks, and we have options to simplify and combine small tanks or to ignore certain tanks of certain sizes. So I think the script that we have at least gives you some guidance on how to put something like that together. But obviously, again, you can always go and look at the generated script that we made and adjust it as necessary. If there's specific cases or specific considerations that you want to implement, that's where this Python scripting interface is really, really powerful in what it can allow you to do. Like, we are trying to provide a very solid basis and foundation of tools and scripts that are giving some of the standard and normal and regularly encountered types of situations. But there's lots that you can do above and beyond that if you have a little bit of Python knowledge and you can leverage the APIs that we expose in our software. So I see one question. Could you illustrate how to add an analysis package? Okay, so the analysis packages that we come with are in the tools. In the tools ribbon bar, there's an analysis package, and these are going to be all of the ones that we have put together, and then you can basically decide on whether you want to load it or not load it. If you wanted to, take this damage case generation package and write additional scripts or add items to that script itself, we actually have a way to create a new package. This button up here, create new package from selected files. So you would have to put the files together that you wanted to put into the package. So if you had additional scripts for the damage case generation tool, you'd have to write those and save them where you wanted. But then from there, you could make a package. It basically asks you which files to add to the ribbon, and you can go through and pick which files you want. And then it goes through that process. And basically, an analysis package is effectively a zip file of any number of Python scripts, models, document files, SQL queries. There's lots of things that can go in it. I do believe we have a portion of the help document that kind of goes through that process of putting those together. Are there any other questions, any other comments? If not, I would just like to say thank you to everyone for coming in and joining. Like I said at the beginning of the webinar, we will be planning on trying to do these pretty regularly, probably once a month, where we'll pick a topic or something to spend a little bit of a deep dive into. This one was kind of a high level look into just kind of some of the main features of the program and kind of giving some examples of the powerful tools and the powerful way we have of doing things. I think the next few that we'll do, we might try to take a more specific feature or a more specific function and do a little bit more of a deep dive into things. So just keep an eye out for those. For everyone that's on, that actually has HECSTAB or HECSTAB on annual maintenance, you should be getting these updates pretty regularly. If you sign up, when you register the software, you have an option to sign up for the email list. So we send them out through a couple of different ways, but that's going to be one of the primary ones. We'll also put it on LinkedIn and put links out. We are also going to be putting these on our YouTube channel. So we'll do a little video processing and get this posted on YouTube so you can come back and review. And then, like I said, all of these tools, all the tutorial document and the example files that we have will be included in this next release, which we have scheduled for the end of this week or maybe early next week. So keep an eye out for that. In the meantime, just continue giving us feedback, asking questions. Don't hesitate to contact us with anything. And thank you very much.